Okay, learning outcome 3. I can calculate central, exterior, and interior angles. And now things get tough. This is a tough learning outcome, but you can do it. Just stay with me. You can do it. Okay, this is a regular hexagon. And you'll remember from last time, a regular hexagon means that all the side lengths are the same and all the angles of the polygon are also the same. So this is equal to this, is equal to this, is equal to this. Everything's the same. Okay, so the question is, what is the central angle? And by the central angle, we mean the imaginary angle from the center of the figure to each of the vertices, right? So if you make an imaginary line from the center of the figure to this vertice and the adjacent vertice, what is that angle? If you remember from the beginning of learning outcome 1, way back 2 learning outcomes ago, that if you go a full circle, that's going to be 360 degrees, right? A full circle is 360 degrees. And because you know it's a hexagon, you know there are going to be 6 central angles. Well, let's count them up, right? Here's one, the triangle made or the angles made between these 2 vertices. Here's another between those 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 2 vertices. And here's the last one between those 2 vertices. So count them up. 1, 2, 3, 4, 5, 6. It's a hexagon. There's 6. There's 6 central angles. So if you know a full circle is 360 degrees and you have 6 central angles, just do some division. 360 degrees divided by 6 is 60 degrees. We have a regular hexagon, and I know through this math here, without getting my protractor out, that the central angle, imaginary lines here, is going to be 60 degrees. Okay, stay with me. We have another regular hexagon, and this time the question is, what is the exterior angle? First, what do we mean by exterior angle? Well, if you have a side of this hexagon and you continue the line out, you'll have an angle between that line and the next side of the hexagon. So I think the picture does a better job than I can with my words. It's that angle right there. All right, so from 2 learning outcomes ago, we know that a full circle is 360 degrees. So if I start here and I go around a circle, right? It's not just around one single point. It can be around an object. But if I start out here and I travel around this regular hexagon, I'm going to go 360 degrees. Well, how many exterior angles do I have? 1, 2, 3, 4, 5, 6. Surprised you shouldn't be. It's a hexagon. Okay, so a full trip around is 360 degrees. There are 6 exterior angles. 360 divided by 6 is 60 degrees. So each exterior angle is 60 degrees. Does that sound familiar? Does it remind you of anything? Yeah, central angles and exterior angles definitely have some stuff in common. All right, now we go to the tough one. Regular hexagon, what is the interior angle? And there's 2 ways to do it. The first way is the easy way. The second way is the formula that a lot of people know and you should be familiar with. But, I like doing it both ways just to make sure I'm right. But let's start with Formula 1. If you know this straight line is going to be 180 degrees. How do we know that? Well, 2 learning outcomes ago, we learned that a straight line is 180 degrees. So this straight line is 180 degrees. And if you know that this angle here, this point here, this area here, this angle is the exterior angle, which is 60 degrees. So a straight line is 180. The exterior angle is 60. Well, we know that the interior angle here, and they're all going to be the same. Remember, they're all going to be the same. This interior angle is going to be the difference between 180, which is a straight line, and 60 degrees, which is the exterior angle. So 180 minus exterior angle equals interior angle. 180 minus 60 equals 120. So that's 120, that's 120, that's 120, and that's 120, and that's 120, and that's 120. All right, but there's another way to do it. Formula 2. Again, this is a tougher way to do it in my mind, but you should be familiar with it. Okay, total sum of interior angles, the formula is parentheses n minus 2, n parentheses times 180, where n is the number of angles. So that's the total sum of the interior angles. So if you want to think about it another way, that's what is this plus this plus this plus this plus this plus this equal? The total sum of all the interior angles. Now, each interior angle is going to be that divided by the number of angles again. So n minus 2 times 180 is the number of angles, and n minus 2 times 180 divided by n is the measure of each individual angle. Okay, so how does it work for a hexagon? Well, here n equals 6, right? Because, the number of angles is 6 because we're dealing with a hexagon. So 6 minus 2 times 180 divided by 6. Let's do what's in the parentheses first. We have 6 minus 2 is 4. 4 times 180 divided by 6. 4 times 180 is 720, so 720 divided by 6. We get 120. Sound familiar? We got 120 that way using formula 1, and we got 120 using formula 2. Whichever way you do it, you should come up with the same number. So it's a good way to check your work is to do it 2 different ways. I think it's tougher, but you should be familiar with it. N minus 2 times 180, and that's learning outcome 3.